We have another differential equation that we're trying to find the particular solution for. There's a dx, there's a dy. We want to get those to opposite sides. So I'm going to move all the x stuff to the right, keep all the y stuff on the left. Y squared minus 1 dy is already there. To get the dx to the right, we're going to have to subtract xy dx. And this e to the negative x squared was multiplied by this whole dy, so we're going to have to divide by e to the negative x squared to get it off the left side. Also divide by y to get it off the right side. So just cleaning this up a little bit, we have y squared minus 1 over y dy equals negative x dx. So you can simplify that a little bit. There is a negative x, but it's e to the negative x squared. In the denominator, we have an exponent that's negative, so we can shift that to the top and make that exponent become positive. So this green definitely looks better than the blue. It's going to make the problem much more accessible to work with. Get that e to the negative x squared out of the denominator, goes up to the numerator, it becomes e to the positive x squared. Integrating this on the left-hand side, it's a fraction. We're going to actually divide it out. Y squared divided by y is y minus 1 over y. So the left side looks like that. And now the right side, if we think about a u substitution and let u be equal to x squared, then du would be equal to 2x dx. So we want this 2x dx to be out front. There wasn't a 2 initially in front of this, so we also have to multiply by 1/2. We're also going to put that negative 1/2 out front. So we're really going to focus on this part of it, what we have inside of parentheses. The left side, the integral of y is going to be y squared over 2, or 1/2 y squared, minus the ln of y. The right side is all set up nicely. The integral of e to the x squared 2x dx. So we integrated this, integrate this right side, and that's going to be the negative 1/2 that's out front, e to the x squared, plus some constant. So now we've integrated both sides. And this equation isn't that bad. However, as I look on the left and right-hand side, we could multiply everything by 2, just to clean it up a little bit, which makes the left side become y squared minus 2 ln of y equals negative e to the x squared. And then 2 times the constant is still just a constant. So there's no reason to call that 2c. It's still just a constant, so just call it c. And then just a little bit further with this one, the y squared minus, okay, the 2 in front of the natural log of y. The 2 serves as an exponent inside of the ln, so it's the ln of absolute value of y squared, which means we're not going to need the absolute value. So it simplifies it even just a little bit more. So here is a general solution. Our goal is to find the particular solution, given that y of 0 equals 1. So we have to understand what this is saying. This means that x equals 0 when y equals 1. It's phrased a little bit differently. So when x equals 0, y equals 1, that means that we can plug that in. So plug 1 in for y, 1 squared minus the ln of 1 squared equals negative e to the 0 squared plus some constant. Right, going further with that, 1 squared is 1. The ln of 1 is 0, so that's gone, equals e to the 0 is 1. That's a negative e to the 0, so negative 1 plus c. Solve for c. c is equal to 2. Now that we've figured all that out, we have the general, we have the specific value that we need, which means that our equation is going to be y squared minus the ln of y squared equals negative e to the x squared plus 2. There's our specific equation. And unlike the other one where we raised e to the power on both sides to get y by itself, the y is already squared. We have an ln of that same y squared, so I don't think that'd be a good idea. Let's just go ahead and leave it like this.